Alright, so this is lesson 3 on torque. It deals with the center of gravity. Do you guys remember the teachings of center of mass? Well, it's relatively the same thing. So for center of gravity, the equation looks like this. The center of gravity is equal to the weight of the object multiplied by the distance of the object, and then you add all the other objects and so on, divided by the weight plus the other weights, and so on. Where x is equal to the distance and weight is equal to 9.81 multiplied by m, your mass. So that's basically the introduction for the center of gravity. It's actually extremely useful to use your center of gravity when the object is in equilibrium. So when problems ask you about equilibrium, you can just use the center of gravity to solve it. I'm sorry about that switch. Yeah, I'm pretty poor using this app. Alright, let's work on some problems. So, a person is standing on level floor. His head, upper torso, arms, and hands together weigh 438 newtons and have a center of gravity that is 1.28 meters above the floor. His upper legs weigh 144 newtons and have a center of gravity that is 0.76 meters above the floor. Finally, his lower legs and feet together weigh 87 newtons and have a center of gravity that is 0.25 meters above the floor. Relative to the floor, find the location of the center of gravity for his entire body. Okay, so all the Newton values they gave you, they're going to be negative because they're going to be pointing down because it's the weight of a person. So to start off, we're just going to draw this out. We're going to draw a little person. Sorry about the mistake. Yeah, I have to make it perfect. So there is 1.28 meters, and then there's distance from the floor 0.76 meters, and there you have 0.25 meters. Let me make it color coded for you. And then right there is the negative 87 newtons where his legs and feet together weigh, and then there you have the 144 newtons of the 144 newtons of his upper leg weights, that is 1.28 meters above the floor. And finally it's 438 newtons of his upper torso and his arms and head, and then it's the 144 newtons in green of his legs. So this is what it looks like. The reason I color coded it is because the blue together shows the newtons and the distance, and then the red together shows the newtons and the distance, and the same thing for the green. It just shows it in pairs so it's easier to understand. Alright, so there's the equation you need to use, and there I labeled the arrows and the distances for you. So from there, you just plug in those values into that equation, and once you get all those values, you should get 1.034 meters, and that is the center of gravity of his entire body, above the floor. Alright, another problem. The drawing shows a person who weighs 584 newtons doing push-ups. Find the normal force exerted by the floor on each hand and each foot, assuming that the person holds his position. Alright, so first thing you gotta do is that you have to realize that your guy is in equilibrium. So his net torque is 0, which is also equal to your torque 1 and your torque 2. That means that 0 is equal to torque 1 plus torque 2. Okay, so let's break it down. We know that torque 1 is going to be equal to force 1 times R1, and torque 2 is going to be equal to force 2 times R2. And we know that R1 is 0.84 meters, and that R2 is 0.41 meters. Since his weight is negative 584 newtons, and we know that he's in equilibrium. We know that the two forces exerted by the feet and the hands added together have to equal positive 584 newtons to cancel out that negative 584 newtons. Okay, so using basic math, if you subtract F2 on both sides of that equation, you know that F1 is equal to 584 minus F2. And the reason the radius R1 is a negative value is because his center of gravity is right here. Is right here. It's right there. And based on position, since it's to the left, it's negative 0.84 meters to the left. And 0.41 is positive because it's 0.41 meters to the right. So, since we had said that torque 1 is equal to F1 times R1, we know what F1 is. So F1 is 584 minus F2. And we know what R1 is, which is negative 0.84. We also know what torque 2 is because of the values given before. So torque 2 is going to be 0.41 F2 because it's 0.41, which is the radius, times the actual force F2. We also know that torque 1 plus torque 2 is equal to 0. So using the values we just found for torque 1 and torque 2, we substitute for torque 1, which is that large value, multiplied by 0 plus 0.41 F2 is equal to 0. Now, using your math skills, just isolate for F2 and see what it equals to, and you should get that F2 is equal to 392.45 newtons. Now, let me make this easier for you. Okay, now how do we find F1? Well, you know the equation at the top, this one? Sorry, that's messy, but yeah, that one. You just plug in F2 for that, and you isolate for F1, and you end up getting that F1 is equal to 191.55 newtons. Now, that's for both feet and for both hands. The question asks you for each foot and each hand. So now the next step is to separate those forces between their hands and their feet. So we had said that F2 was 392.45 newtons and it represented both hands, and F1 represented 191.55 newtons and it represented both feet. So how do you get each hand and each foot? It's really simple. You just divide them by 2, and then your final answer should be this for each hand and each foot. So see, it's not that bad. Alright, let's do the next problem. Ignore the first sentence. So, workers have a loaded delivery truck in such a way that its center of gravity is only slightly forward of the rear axle, as shown in the drawing. The center of gravity is this little thing right there. The mass of the truck and its contents is 7,460 kilograms. Find the magnitude of the forces exerted by the ground on the front wheels and the rear wheels of the truck. Okay, so this is really similar to the problem we just did, if not exactly like the problem we just did. If anything, the problem we just did is a little bit harder because you gotta separate it for each hand and each foot. Here, you just look at the front wheels and the back wheels in general. Alright, so first thing is find out the weight of the truck. They give you the mass, so you just multiply by 9.81 to get the weight. And it gives you that value, negative 73,182.6 newtons. Alright, and my next step is to draw it out to make it look like it makes more sense. So right there is your line. There you have negative 0.63 meters because the center of gravity is right here, but it's 0.63 meters to the left. And then you have positive 2.3 meters because the center of gravity is right there. It's 2.3 meters to the right, so it's positive. And it's negative 73,182.6 newtons from the center of gravity. And then that's your force 1, which is your front wheels, and your force 2, which are your rear wheels. And the reason they're pointing up is because it's the normal force that repels those negative 73,182.6 newtons. So let's say that those numbers are equal to F3. Okay, so we know that the net torque is torque 1 plus torque 2 plus torque 3, and also that it is equal to 0. Since it's in equilibrium, we can also say that F1 plus F2 plus F3 is equal to 0. Since F3 is equal to negative 73,182.6 newtons, you can say that F1 plus F2 is equal to 73,182.6 newtons. See, this is turning out to look very similar to the last problem that we did. Okay, so we know that those three forces are 0 and that the two forces, force 1 and force 2, are equal to 73,182.6 newtons. We know torque is 0, and now let's separate the values of torque 1, torque 2, and torque 3 to make them easier to understand. Okay, so we know torque 1 is F1 times R1, and we know that R1 is 2.3 meters, so torque 1 is equal to F1 times 2.3, and we know that torque 2 is F2 times R2, and we know R2, which is negative 0.63, so torque 2 is F2 times negative 0.63, and torque 3 is F3 times R3, and we know both values for F3 and R3. We know F3 is negative 73,182.6, and the reason why R3 is 0 is because since it's located right there at the center of gravity, it's in the center, so there's no distance that it needs to cover. So R is equal to 0, and since R is equal to 0, anything multiplied by 0 is just 0, so your torque 3 is 0. So remember how we said that F1 plus F2 is equal to 73,182.6 newtons? Well, using your basic math skills, you subtract F1 on both sides, and you get that F2 is 73,182.6 minus F1. Okay, so also remember that torque 1 plus torque 2 plus torque 3 is equal to 0. So substitute torque 1 with this equation, and substitute torque 2 with that equation, and torque 3. Okay, sorry, what I just showed you was gibberish. Ignore that. Substitute torque 1 plus torque 2 plus torque 3 is equal to 0 with this. This being torque 1, this being torque 2, and this being torque 3. Okay, now, since we know what F2 is equal to, we can substitute F2 with this to solve for F1. Your equation should look like this so far. I deleted the 0 because it's worthless. I mean, you don't really need it there. So use your math skills and distribute like that, and you get this times that is this, and this times that is this. Now you just solve for F1, and you should get your answer to be 15,735.51 newtons. So you know what F1 is, and you know that F1 plus F2 is equal to this number. So now just plug in to find for F2, and you get F2 is equal to 57,447.1 newtons. F2 representing the rear wheels and F1 representing the front wheels.